The question is all red because it's an important question and you guys need to learn it properly. We have a copper wire of resistance R. This wire is pulled so that its length is doubled. Okay. Find the new resistance of the wire with respect to its original resistance. So let me explain the question in this way. So just a second. I have a copper wire, right? The resistance of this copper wire is R. So what what they're telling is they want us to consider the same wire, but the thing is they want us to pull it out. Okay, make the length double. So let me do that. Uh, right, it's kind of double, is it not? Let me just okay, so yeah, kind of. Right. You can see it's doubled. See, when you pull out something, see, it's not like we are stacking two wires. We are pulling it out. So if I pull it out, what will happen to the radius? The radius will reduce. They won't be the same. So what I have here is not the right size. So I need to reduce it. Okay, that's increasing. Reduce it to how much? Can you guess? You have to reduce it to half. Is it not? It will become something like this. Doesn't exactly look like that, but yes. It will become from this to that. So basically the area of more than talking about the radius, I can tell the area of cross section will become half. So a bit fatter, that will help. I think this looks better. Right? It becomes not exactly again, but anyways, you guys can imagine that a bit more fatter. Right? The length has increased, the height has increased to double of it. So this is of length L and this will become 2L. If the area of cross section is A, this will be A by 2. Okay. The resistance of this is R and this is how much? Is it R by 2, R by 4, R by 6, R by 3, R by root 2? What is it? So that's what they are asking. So let's look into that. So we should begin such answer. See, there's no value given. So we have to begin such answer with let the original resistance, original copper wire be of length, copper wire be of length L. And let me be a bit more disciplined. Length, okay, not length L, and area of cross section be 2A. Okay, I'll show you why I have taken 2A. Right, and the resistance is equal to R. This is given. So both are of same wire. They are the same wire. So the resistivity is same. And let resistivity be equal to rho. Okay. So this is so many meters, meter square, and this is ohm meter, and this is ohm. Now the wire is when pulled, so they're pulling the wire, na? When pulled, not pulled, pulled, will have L dash, right? Length will be equal to, let me write it this way. Length will be equal to 12 meters. Okay. Then area of cross section will be equal to A meter square, because the area of cross section reduces by half when you double the length. Reason, when we, as the wire is pulled to double the length. You don't need to give more explanation. This is good enough. That's why I took A, 2A, because 2A by 2, actually let me write that. It's 2A divided by 2. So that is basically A meter square. Right? And resistance we have to find. Resistivity, will it become rho by 2? No, it won't become, because the resistivity is fixed. Doesn't matter what is physically happening to the material. It won't change. It's the same material, right? As it's same material. Is it not? Okay, so we have all the information. All we have to do is, see, whenever you get any question like find the new resistance of the wire with respect to its original resistance, any kind of question, anyhow they're framed, it's always R new divided by R old. So R new is rho L new by A new dividing rho L old by A old. That's all. So now all we have to do is substitute. So rho L new is L itself, A new is, sorry, L is, L new is 12. A new is A into 1 by rho A old, because this will go to the numerator. Old area of cross section is 2A, and the length happens to be L. Right? So now it's just a matter of cancellation. So L A rho rho. So resistance of the new divided by resistance of the old is equal to 4. 2 into 2 is 4. Therefore, R new is equal to 4 times the length of, sorry, not 4 times the resistance of the old one. That's it. Okay, so we can conclude that this is the actual answer, but let's write a conclusion so that you guys get any other question relating to such a nature. You know what it means. See, the new wire has a resistance of 4 times that of the old wire. The reason is simple. One is the length has increased, double. And also the area of cross section also has not increased, but it's halved by 2 times. No, it's halved basically. So there is double the markup in double effect. You are spending more time running from one end to other end, and also there's less space. So it'll take more time for quite a few electrons from moving from one end to the other end. Right. So there is double effect. The new resistance is 4 times stronger or resistive than old resistance. Right. So this should be your conclusion. Okay. If they replace this with any value, it's just a matter of dividing by 4. If it's an MCQ question, whenever you see double, it's just that it will be 4 times. No, the resistance will increase 4 times. If it's tripled, the resistance will increase not 6 times, it will be 3 into 3, that is 9 times. Same question, just put 3 over here. Same result, right? Same expression, same everything. So here in place of 2, it is 3. And in this place, you take it as 3a. So this will reduce to a. So 3 into 3 will be 9. So people want to pause and have a look at the answer. Please do so now.